Hello, my name is Oleksandr Zalugovskiy and I'm a project manager with PortaOne. Today I'm going to shed some light on the important topic of redundancy and high availability. You're going to learn what these two buzzwords mean, how they are different from each other, and how they are implemented in PortaSwitch. And if you're wondering why the default PortaSwitch setup does not already have the highest level of availability out of the box, you will learn the answer to that as well. Let's start with a few boring theory pieces. First, what is redundancy about? In telecommunications and anywhere else, redundancy is a secondary system that backs up a primary system in case the primary system encounters a problem. In Telecom, redundancy is designed to prevent a failure of service and loss of data. This can include anything from simple data backups to having multiple instances of hardware when you technically only need one. Redundancy basically means that you are going to need extra hardware components, for example, multiple power supplies or multiple disks within a single server. It also means that you will have to organize those pieces of hardware into what is called a redundant array of independent disks, or RAD. And that brings us to high availability. The primary goal of high availability is to ensure that your system functions even in the event of a failure of some component within that system. If you have multiple instances of the same component and they are arranged in a high availability system, if you lose one of those components, the system will continue to provide service as if nothing happened. If redundancy and high availability sound the same, it's important to understand that they are not. Just because you have multiple servers or multiple systems, in other words, just because you have redundancy, that doesn't necessarily mean that your system is highly available. High availability means that the systems will automatically use one of the available extra components to replace the failed one. In a high availability system, this will happen fast enough that end users do not notice anything. If you only have redundancy and not high availability, your administrator may have to flip a switch to move from one server to the other, or you may have to power up a new system to make it available. High availability, on the other hand, is generally considered to be always on and always available. So, before we move on, let's recap these two definitions using a simple example. Redundancy is when you have two servers running an application, for example PortaSwitch. High availability, on the other hand, is creating a system in which if one of those two PortaSwitch servers goes down, your services are automatically switched to the other server so quickly that the end user does not notice. So, how is redundancy and high availability implemented in PortaSwitch? Let's start with the main PortaSwitch components. All of these components like PortaSwitch, PortaBilling, and the web instance can be deployed on multiple servers. They can also work in clusters that conform to high availability standards. This provides extra performance, since incoming requests are distributed for processing among all of the available servers. It also offers improved reliability. For example, if one of the servers is down due to a hardware failure, the remaining servers will continue operating. PortaSwitch, PortaBilling, and Web Clusters technologies are included in PortaBilling with Oracle Real Application Cluster, or RAC, and with PortaSwitch clustered products. Here I have to note that there are some exceptions. Specifically, these relate to the configuration server and the database servers. The configuration server stores the information about all the other servers in the installation, along with the service configuration details about each of them. The configuration server monitors the status of all the other servers and also collects log data such as SIP communication logs from PortaSwitch or billing engine logs from the billing nodes. This server is not involved in any real-time activity, such as connecting calls or processing charging requests. This means that a temporary failure of the configuration server will not affect services at all. For that reason, periodic backups are enough, and it is safe to omit expensive high availability for this server and instead rely on manual server restoration from the backup. For more details regarding any of the PortaSwitch components that I've just mentioned, please check the links in the description of the video. Now, let's discuss the options that PortaOne offers for the database servers. The first is a MySQL-based database server, where the redundancy concept is based on having main and replica databases. Here is how this works. The main database server hosts the primary copy of the database. This database is used for all real-time data access, for example, during account authentication, and for all data modifications. The replica database server, meanwhile, hosts the second copy of the database. This database is used for all data mining activities, for example, calculating a summary for an invoice or producing reports. It can be used to restore billing data in the event that the main database is lost. You also have the option to equip PortaSwitch with a standby database for quick disaster recovery in case your main database server goes down, for example, due to a motherboard failure. This standby server is identical to the other database servers and has the same software installed. The only difference is that during normal system operations, the standby database runs in secondary mode, with a real-time replication, and so is fully synchronized with the main database. It's important to understand here that a standby database is not a panacea, meaning it does not protect you from all circumstances. It just leaves your database redundant in case of a main database failure. Also, this setup won't help in a situation where your colocation provider has an issue with network connectivity, as in this case, all servers will be affected. In my next video, I'll describe what option PortaOne can offer to cover that scenario. The main thing to remember with this MySQL option is that switching to the replica database in case of main database failure is only redundancy, not high availability. It requires system reconfiguration and it has to be done manually. This can be done in about 5 minutes, but still, it will not be automatic and it will not be immediate. Now, let's look at our second option, which is based on Oracle Real Application Cluster, or RAC. RAC allows PortaSwitch customers to run a single Oracle database across multiple servers in order to maximize availability and enable horizontal scalability. By horizontal scalability, I mean that additional servers can be added to the cluster to linearly increase capacity. With this setup, in a situation where one of the RAC servers fails, the database will continue to operate. As a result, the impact of an outage will be hidden from the end users. So, unlike the MySQL solution, Oracle RAC provides redundancy together with high availability. However, it does require additional hardware for shared storage. For more details regarding the Oracle Real Application Cluster, see the link to the Oracle website in the description of this video. I hope you found this information useful. In our next video, I will discuss geo-redundancy, integration platform as a service redundancy, and a few high availability peculiarities in PortaSwitch. If you want to make sure you don't miss it, please subscribe to our YouTube channel. Meanwhile, thank you for watching.